So welcome back, everybody. Um, this week we're going to start our last project of the course. Oh, we have 2 weeks left. Let me look. Next week. Maybe we have like 2 weeks and a few days or so. So we'll start our last project today. So let me post that right now, actually. Classwork. Create. Brick Breaker. It's a good project to learn a whole bunch of different things that we need to know. And, oh, there we go. Got it. So, let me share that on my screen here. Share my screen. Hold on, I got way too much stuff open now, I'm confused. Alright, present now. Your entire screen. There it is. And there's the Brick Breaker assignment. How do I get back here? Instructions. It's not much to it. Create a Brick Breaker game using structures. We'll talk about that today. In a separate file. That's going to be important. The game must include a unique design, power-ups, and good battle mechanics. So, I'm going to get you started with that for the next few days. We're going to just slowly build this thing together. And if you're not done your assignment too, that's okay. You got lots of time. Got a month still. Okay, so don't panic. And if I didn't get back to your email, just let me know today and send me or I'll have your code and I can look at it today. Last week wasn't very good because I went to Sarnia with my family. It's just to chill with my mom, so I wasn't at my computer very often. Alright, so let's create a new project. Can you all see the screen and everything, hopefully? And let's create a new project, and we're going to make it a Box2D project so that we can use the collision and everything. Give it a name with no spaces and no symbols and no weird stuff. I'm just going to call mine Brick. And there it is. It's that same old program. Okay, so I guess what I'll do is remove that stuff. I want to keep some walls, but probably not have them on the screen. Like if I could take this wall and just move them down, however many, so that it's still there, but I don't see it. That's going to be good for a Brick Breaker game to have walls. Maybe not necessarily on the bottom, but definitely on the sides and top. I'll keep this one on the bottom. Instead of writing 570, I'll write 600, because that's the edge of my screen. Just keep a small window for my screen again. Let's see if I can, if that's still there. That's good. And then I'll add another wall on the roof. Just gonna copy that one, paste it. But I'll write like maybe minus 30. Okay. Did that put one on the roof? Let's check. Let's make the gravity minus 9.8 instead and see if it hits. Yep. Cool, eh? That look weird. So what a natural test to see something floating up. Alright, So there's top and bottom. I'll paste that again and make one on the left and the right. I'll say this one's 0, 0. Maybe I'll put minus 30 there on the left. I don't think that needs to be 800, does it? No. This is going to be a little different. I think this needs to be 600, and this needs to be 30. So it's 30 wide, but it's 600 long. Let's make, so that should give me a wall on the left, right? I want to test that. I'll just write minus 9.8 there. Let's see if it makes a wall. Yeah. Cool. And then I'll make one more wall, finally, on the right side. So I'll just say this one is going to be 600. Oops, 600. 0, 30. That should make it on the right. Let's test it out by just having our gravity swoosh. Oh. I should have said 800, shouldn't I? Not 600. Yes. Good thing I checked. Ooh, there we go. Walls. No one's escaping ever. Alright, there we go. So, what we want to do today is add some files to our project. And, well, what we could do, let me get my little pen here, little notepad here. Hopefully you can see that. There it is. Let's see if I get a pencil. Draw. Okay, so we got all our code here, right? There you go. This is going to be the code for our project, you know, like int. Wow. That's messy, and all that stuff there. And then all our code for our project, right? And we could add, what we want to do is we want to add our own variables. So we want to be able to, for instance, we want to be able to write the word ball and then go B1 and have all kinds of options associated with it, like just like any other object that we've worked with, like SFML ones, for instance. Like if I make a circle shape or whatever and type C1, and then I can write C1 and look at all the little stuff I could do to it. We want to make our own object like that, kind of our own super variable. They're called objects because they're more than just variables. They can do a lot, right? And the other neat thing about circle shape is when you make it, you can actually type stuff in brackets to kind of set some of those options right off the bat. Circle shape's kind of boring. You can only set the radius and the point count. We want to make our own of that. A ball. We want to make a paddle one, where you type paddle P1. We want to make a brick one. Maybe we would even want to make a power up one later on, right? So to do that, we're going to use these things called classes. I call them structures for now. And they're basically just new and improved variables. Okay? So what we're going to do is, I mean, in the past we would have just wrote all this code in here to make our ball object and our paddle object and stuff like that. But that's going to get kind of messy, so what we're going to do is we're going to take this code and move them into separate files that are all on their own. Okay? So we're going to have a ball.cpp file here and a paddle.cpp file here, and then it's easier to work with them because we'll have them in separate files. Okay? I haven't really done anything like that before. A lot of code that you'll see on the internet and stuff and in books is they'll always have this tiny little main file. They'll have this tiny little main, and then all of their code will just be in all kinds of separate files all over the place. It's called object-oriented programming, and Java is the worst for this. You could make like the smallest little program, you know, Find a program that like takes a list of numbers and orders them or something, and Java will have them all in these like every little piece of it will be in a separate file. And then the problem is like this file can talk to this file, but it can't talk to this file. And then this file can talk to this file and this file and this file, and you can see why I call it spaghetti code, right? And then this guy can talk to this guy and that guy, but he can't talk to this guy, and you know, it's just messy and dumb. I like to have most of my code just in a big file. Back in the day, I think it was more important to do this because it took computers a long time to compile code. That's not the case anymore. As soon as you hit F9, your code runs pretty quick. Even if it was 100,000 lines, it would still run pretty quick. But in the past, the argument was you would compile these separately, and if you didn't change anything, they didn't need to recompile. So it was quicker to compile your code, because when you hit F9, it only updated the ones that got changed. People still code like that all the time. I'm not a huge fan of it. So let's add a new file to our project. So we'll right-click on Brick, I guess, and we'll write Add File. Will that work? No. Maybe what we'll do is we'll go File New, okay, and we'll just do Empty File. It asks you if you want to add this new file to your project, and you say yes, okay, or else you'll have to go into the settings and like actually add it. Pain in the butt. Okay, so I'm going to call this one ball.cpp. There's .h and .cpp. They're a little bit different. My physics is a .h and my ball is a .cpp. And we're just going to avoid .h files for now. Basically, when you make your own variable, usually you would add two files, a .h and a .cpp. The .h would just have a list of all the commands, but no code, and then the .cpp would have the code. It's kind of a redundant thing to do. It's still done everywhere, but I'm not going to do it for this project. Too much confusion. Oh, look at that. Okay, so now I have this ball file in my main, or in my sources there. Okay, so what I can do now in my project, just anywhere here, is include it, because it won't know to include it yet. And you put it in ball.cpp. Let's see if that works when I run that, if I get any little error messages. Nope, it runs. So what the code does when it hits F9 is it basically finds this file, and it actually physically pastes any code that's in that file actually right here. Okay, that's all it does. It doesn't. There's no magic to it. It just does it inside the computer as it's like building your program. All right. So let's create our own ball structure. So you just write the word struct like that. Okay. You give it a name. I think that's all you do, and then you add empty brackets. Done. And when I run my code, there you go. Now, if I type ball here to make a ball, will it auto type? Yeah, it does. Look at that. Ball, I knows. You made something. Okay. Call it B1. Whatever. I mean, you could do a vector of them later on. If you're going to do a power up where your ball splits into 3 balls or something like that. Weird. And that's it. We obviously have to add a lot of code in there to make it much more dynamic than this, because right now it does nothing. Okay. Why don't we do something where this is a cool idea in coding. It's overused a lot, but I'm going to include, #include. Any kind of library you want to use in here, you have to include, even if you've already included it in the main. Okay. So what I'm going to actually do is include physics.h, because physics.h has a lot of the stuff already included. If you go to physics.h, it has SFML, IOStream, and Box2D stuff. So we'll include that, and that way we can use those commands in our new file. If we didn't, it wouldn't know that. It would be fine because they've all been included up here before we actually pasted this code in, but the auto typer and everything won't know what's going on, so we'll just re-add it here. And that should give us all the SFML stuff. And why don't we do using namespace SF. That allows us to avoid, what's this one here? Typing SF : in front of every or SFML command that lives there. So if I run that, there we go. And then here was the interesting thing I wanted to say was, I think if you write : after the name of your ball and you write public circle shape, it will take on all the properties of circle shape. So basically I've created my own variable and all it does is copy everything circle shape it does. Let me see if that runs. It's been a while since I did this. Yeah, it does work. It compiles anyways. This is called inheriting. Inheriting all of circle shapes commands, right? And that's important when you're making these objects. You don't want to have to reinvent all the code. I mean, you do want the ball to have a lot of the properties of a circle shape, right? Because it's got to draw. It's got to you got to be able to draw it down here. You have to be able to like resize it and all that kind of stuff. So we want to have it take on those properties. If I hit B1 and hit dot now, you can see that it can do anything I want now. Okay. So for instance, if I do set radius, right, and I go whatever 60, I could actually go to window.draw somewhere in here and draw the thing, and it will draw it because it has all the properties of a circle shape. So B1 was the name of my ball. Okay, so I haven't really done much except renamed. There it is. Basically renamed circle shape into the word ball. Okay. However, the plot will thicken here. Let's add some variables in here that we can use. I always like to add them at the end. And they're called member variables. Excuse me. So I'm going to give, I'm going to have to come up with two variables for this thing for now. A speed, okay, and an angle, float angle, like that. Those are going to be important for my ball when I get to coding it. And let's see, what else do I want to add? I actually want to add a block. I'm actually going to call it B2 body though. B2 body star. And I guess I'll call it body. Box2D body. This is going to be my window into giving this thing like physics stuff. If you go to physics.h, you can see that that's what a block is, right? It's called a B2 body with a star in front of it. It's just the memory address of the B2 body object Box2D uses. And then from there, if I want to do anything, I'll just like set it on the Box2D body. we'll see. I'll show you. We'll copy a lot of the code from create circle, okay? So that we can avoid recoding that as well. And we'll get this thing to bounce off the walls and everything like that. Let's run it and see if it runs. Okay, cool, it does. Alright, so that's all we got so far. Maybe what we'll do is just copy that create circle code. We obviously don't need this return statement, so we will not copy that, but we'll copy all this other stuff. Okay? We'll just go through it line by line and see what we need. So before I copy that, actually, let me make this thing called a constructor, because that's where we're going to actually copy it in. So what you do is you write the name of, is this how you do it? Yeah. You write the name of your actual structure, and then you write empty brackets, and you basically make a function that's the name of your structure, and then this code will run only once when you make your object. So for instance, let's do this. If I do something like cout hello in here, okay, and then I got created, okay, and then I go here, you'll see once I call this, once I make the ball, that code will run once. Okay? So it gives you a chance to launch some code as soon as your thing gets created. It's called a constructor. Let's see. There, he says it. Hello, I got created. Okay? So it's important because a lot of these things, like for instance, remember when I made a circle shape, the simple one, if I put something in brackets, that's the constructor. You can actually pass it stuff as well. Okay, so every object like that, every variable that's got all those commands associated with it, will have a constructor built in so that you can launch code the second it gets made. You can even pass it stuff, like for instance, float, I could do S and I could do float R like this, okay? So now I'm forcing the person that makes it to set a speed and an angle. And I'll leave that code in there, oops. So now this won't run anymore. It'll say I was expecting 2 arguments. So now when I type B1, you'll see it's expecting me to give it a speed and an angle, for instance. So maybe like 40 and 45 or something. Okay. There we go. Now these 2 are just dummy variables. They haven't actually set my speed and angle, but if I want to set them, I can go speed equals S and angle equals R. Oops. Okay. And that'll actually set the variables that are in my ball to those whatever numbers, whoever typed the numbers. So now my speed of my ball and my angle are set. It's actually kind of nice. And I could later on, I could actually even print those out if I wanted. I could go cout B1 dot, and I could spit out its angle like that. Okay. Hello, I got created, and it spits out the number 45, so it knows. Alright, cool. So once we have that constructor, now I think we'll paste our we'll paste all this box2d code in there. We only need to call it once. Okay, so let's do it. Whoa. And we'll just go through it a little bit to see what we're missing and what we need. Okay. So this is all fine. This body definition looks like it sets up a position on the screen, and it also gives it a type. These are things we're missing that physics actually had in the, do you see that? So create circle was passed a world, an X, a Y, an R, and a body type. We're gonna have to pass all this stuff to our project as well, right? It's not gonna know what any of that stuff is. So let's paste all of that stuff in there as well. I'm actually gonna rearrange this to maybe put it after. Whoa. There we go. So ball is now going to request the world, an X, a Y, a radius, a speed and an angle, and a body type. You don't have to type a body type. We'll default it to dynamic body. But that way we aren't missing this X here, right? It's looking for an X, it's looking for a Y, it's looking for a world variable, it's looking for a bunch of stuff. It appears to set the linear dampening to 0.5, but for our Brick Breaker game, we'll set that to 0. Okay. Then it makes a circle shape. It sets the shape, sure. Density. We'll set the friction to 0 as well. Restitution we'll leave at 0.5, I guess. A lot of this stuff has to do with Box2D is weird. It has like everything has a body definition which defines where it is in the world, and then a fixture as well, which defines a lot of its properties like density, friction. I don't know why it's like that. It's just a reason. Somehow to deal with all the physics that goes on. Okay, so that's all good. Here's what we're going to change though. Here's the important thing we're going to change. In my physics.h file, it would actually make a block object and then like dump it into the world, okay? And then it would also take that body that we made, that physics body, and give it an SFML shape here. So we have to change that a little bit to say, instead of actually making a new variable here, we already have this variable we made body. That's going to keep track of everything that we have in Box2D. Hopefully we don't need to worry about it too much and it just works under the hood and we don't have to think about it, but we don't have to make a new variable in our constructor. It doesn't make sense to do that. We're just going to write body like that because that's going to be our link to everything. And then here, instead of the word res, we'll write body. Oops, bitty. And this is all fine. It's gonna like set a circle shape to it and everything. We could change the color later if we want, but right now it will be white. And then instead of res, we write body. So we replace all the reses with body, and we actually don't even make a res variable. That's the only difference. And then I changed the friction and the linear dampening as well. But now obviously it's going to bark at us because it was expecting 7 arguments and I only gave it 2. So that's my physics.h. Actually, this is the one I want. Okay, so I'll leave that up there for a second. What did I change? I changed this. I changed anything from res to body. So body, 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 and that's it. Good. I think this line here actually had, let me just check. It had B2 body. Don't need that. Don't need to remake the variable. You just write body. That's our variable we'll keep track of. Body and body. So I think now, even though we haven't really done much, this will actually, when we make our ball, it will actually dump it into the world and have it move around and stuff. And it will be exactly the same as just like a physics : create circle. It will be, it's almost identical to that. The only difference for now is that we can, it's our own variable first of all, so we're going to actually add way more to it for sure. Right now all we have is a constructor, but we'll be able to update its speed and angle too later with a command. We don't have any commands in here to actually update the speed and angle. V2 body type. Yeah, make sure you have V2 body type isn't declared. V2 body. Make sure you have physics.h included at the top, Marco. V2 body. It's the only thing I can think of why that would not. Why that would crap out on you. I'll paste this in the Google Classroom, all of this code for now. Just copy and paste it if yours doesn't work. That right now. Bam! Alright, it's on the Google Classroom. So try that if you can't get it working. Okay? Let's go to our main and actually create this ball now and give it everything it needs. So it needs a world, sure. It needs an X and a Y. I always just put it in the middle of the screen. It needs a radius, 50, sure. It needs a speed and an angle. These don't matter right now, but I'll give them both 45s, 45s. It needs a body type. I'm going to just not type anything because the ball should be dynamic. It should be able to bounce off of everything. Now, that's good. I don't have my draw command in there anymore. Display world actually should draw it for us. So let's run it. Do we have gravity still on? It should have a ball that like bounces off the wall. There it goes. Kadoom. There's our ball object. You can see that you can see the issue here with the bounciness of it. The restitution is not good. Right? What I'm going to do to fix that is I'm going to actually just go into the physics.h of this project right here, and I'll set the linear dampening to 0 here for the create box because that's what's making the walls, and I'll set friction to 0 and restitution to 0, and that way my wall should be much more bouncy. Because I did already set that in my ball, right? Here. I didn't set the restitution in the ball code, but I set the other things to 0. So this should make it much more bouncier. Just normal. Maybe it's 1. Is restitution 1? Alright. And the ball's restitution is 1. Apparently 0 makes them sticky. Kadoom! There we go. We're not going to have gravity in our project, so we're not going to have to worry about that kind of parabolic motion that it's moving at right now. But that is the ball bouncing around. Okay. Now, why don't you see if you can get that working, and I'll we'll get back together at 10 p.m. 10 a.m. Okay, so get that code typed up, and then we'll come back and we'll add some commands at 10 a.m. Okay, and I'm just gonna go get some breakfast. I'm hungry.